So in this video, we're going to look at another way of listing and looking at possible events, and that is with a two-way table or sample space diagram. So a six-sided die and a coin are tossed, list all the possible outcomes. So one way to think about this is, rather than just do, like in the previous video, a systematic list, is to create something that is known as a sample space. And that is really a two-way table where one event is on one side. So let's have the dice along the top, and of course we could have a 1, 2, 3, 4, 5, or 6 on the dice. And on the left-hand side, we could have the coin, and the coin is going to come out at either a head or a tail. So the reason this is useful in this case is because it's equally likely to happen on every event on the dice and every event on the coin as well. Okay, so if we have these on the sides, then inside the sample space, we can list the combination of things happening. So for example, we might write 1H there, 2H there, 3H, 4H, 5H, and 6H, and that represents that particular possibility. We're going to have 1T, 2T, 3T, 4T, 5T, and 6T there, representing, for example, here, getting a 2 on the dice and getting a tail as well. So that is the possible outcomes, and I've listed them using a sample space. So now let's look and see if we can figure out how to use this sample space to work out probability questions. So two dice are thrown together and find the probability that the total score is 9. So we're presuming here that when we throw these together, we add the numbers. So let's draw out a sample space for this. And we've got two dice, so we're going to have 1, 2, 3, 4, 5, 6. So we call this dice 1. And 1, 2, 3, 4, 5, 6 here, and we'll call this dice 2. So each one of these events inside the diagram represents a possible thing that could happen. So for example, that 2 represents the chances of getting a 1 on dice 2 and a 1 on dice 1, right? They add together to make that 2. So let's fill this out very quickly. With the sum of the two numbers. So I'm writing 4 there because it's 2 and 2. I'm writing 5 here because it's 3 and 2. Right, let's finish this off nice and quickly. Okay, so there's my sample space. So what is the probability that the total score is 9? Well, first of all, how many different possibilities do we have? Well, 6 times 6 is 36. So this is going to be each one is equally likely. So this is going to be something out of 36. So how many of those 36 different equally likely outcomes is a 9? Well, we have 1, 2, 3, 4. So our answer is 4 out of 36. We can divide them both by 4. That's going to be 1 over 9. Okay, let's consider another question. So, a spinner which forms part of a children's game can point to one of 4 regions, A, B, C, or D, when spun. What is the probability that when the two children spin the spinner, it points to the same letter? So our sample space diagram in this case will look like the following: A, B, C, D, A, B, C, D. Maybe this is child 1, maybe this is child 2, doesn't matter. Okay, so let's fill in this table. Well, I'll just write A, B, A, C, A, D, B, A, B, 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 C, B, D, C, A, C, B, C, D, excuse me, making mistakes, C, 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 D, D, A, D, B, D, C, and D, D. Okay, so we have in total 16 different possible outcomes, all equally likely. So how many are there that are the same? Well, we've got 1, 2, 3, 4. So it's going to be 4 out of those 16, which is a quarter. Okay, Final question. Let's have a think about this. In this question, the table is provided for us, and it is very similar to that first table, isn't it? Right. So we've got a coin and a die, and we've got to quickly complete the table. Well, let's do that very quickly because we've already done it once, haven't we? H2, H3, H4, H5, H6, T1, T2, T3, T4, T5 and T6. Okay, so what's the probability of obtaining a head and a 6? Well, that is going to be 1, isn't it? There out of 12. Okay, there are 12 in the table, so we're going to have 1 over 12. Okay, on to B. A tail and an odd number. Right, so how many is there with that condition correct? 1, 2, 3. So this one is going to be 3 out of 12, which is, of course, 1 over 4. Next one, a head and an even number. Okay, 1, 2, 3 in this case. So again, we've got 3 over 12, which is a quarter. Next one. A head and a number greater than 2. So that's not including 2 itself. So that is 1, 2, 3, 4. So that will be 4 out of 12, which is a third. And then finally, we've got an even number. Let's use a highlight for this one. So 1, 2, 3, 4, 5, 6. Those are the possibilities where we have an even number. So it's going to be 6 out of 12, which is a half. There we go. Nice and straightforward.